Good morning. So, today we'll be doing the last chapter of this course, Transportation Management. And before I start the lecturing on this chapter, I'd like to thank you for coming to this class and uh, listening to my lectures, going through the slides, going through the handouts. I know that in online course I cannot really explain to that details in which we do in class and have more interaction with students. So that's not possible in this online class. Um, but I suppose on the other hand, it serves some purpose for you that you can go to work and maybe take this course at your own convenience. I would encourage you to communicate with me between now and before you take your exam too, so that if you have any problem, please let me know, and I'll try to uh, look into some of those problems which are there regarding some of the lectures or regarding the test or quiz or anything related. So let us get started this chapter 14, which talks about issues and challenges of global supply chain. Now, all the while we had looked into different aspects of transportation. What are the factors which create the demand? What are the factors which determine the cost um, at which the transportation can be provided? We had looked into the competition, we had looked into different modes of transportation. We had looked into transportation from um, supply chain perspective, like what are 3PL services, what are 4PLs, and so on. So in this chapter, we'll specifically look into transportation from the perspective of global supply chain and what are the challenges which this global supply chain is facing. So let us get started. Introduction. In this slide, we'll basically try to recap whatever we have done previously. And we have said before that transportation is the backbone of the economy. It helps uh, boost economy of a region. It helps political. Um, uh, it helps to develop a stable political uh, climate. It helps in social development. So any sort of these activities related with social, political, economic, they are basically influenced a lot by transportation. There had been a decline in the fuel cost, which has actually lowered the transportation cost, and it has also helped to improve the service in a big time. But that decrease of transport, the fuel cost is not consistent. It seems that the market is more volatile. Sometimes there are some spurs where there increase of fuel cost, so that in turn will affect the transportation service. It affects the cost at which transportation service can be provided, and in that way it will affect the demand as well, because we know that the demand uh, is related with the cost at which it is offered. The, the other problem in transportation, or another big issue is transportation, is the capacity constraint. At a lot of vital locations, we see that there are capacity constraints, there are bottlenecks, like in the ports, um, which are basically the link to international destinations. Their bottlenecks, like the port of Long Beach or the LA port, they have got huge capacity issues. The other problem is transportation is very much related with environment pollution and transportation um, are very much intertwined. We have seen that as the transportation service increases, the environment pollution also increases, and a big burden of lowering pollution falls on transportation planners and auto manufacturers. So that's another issue we'll look into in this chapter. As we said, that congestion in transportation industry or transportation infrastructure is a common phenomenon now. Now in many of the ports, uh, both ocean both like ocean ports and also in airports, there are congestions. If you go to the DFW airport, you will see that uh, some of the flights cannot land at the right time because there is a congestion in the runways. They have to kept in queue because the runways are not available at the right time. The ocean liners, they have to be kept waiting out in the water before they can get a berth to uh, basically dock their vessel. So these are some of the issues. Even when you drive in the streets of Dallas, we see so much of congestion. Um, One aspect of congestion is it takes more of our time, as far as our travel time is concerned, as far as the travel time of freights are concerned. Uh, it is a excess cost of fuel when you are stranded out in your car in the traffic. It's burning fuel without actual um, the the transportation activity getting done. So that's a big problem. But that's not the only problem as far as supply chain is concerned. Because of the delay, because of the congestion, companies have to store more inventories. They have to have more safety stock because the goods are not delivered in the right time. And that excess cost, that excess inventory means cost to the company. So basically, it is an add-on to the existing uh, inventory cost, which is again which again passes on to the consumers as an excess cost to consumer goods. So that's a very much an adverse effect of congestion on the economy as a whole. The other aspect of congestion is uh, it not only affects time, uh, it not only affects cost, but it takes away valuable time from the consumers, from the people, which can be used for other production activities. So the time when you could have spent in your office, probably in your with your books in campus, is wasted sitting in the traffic. So that's also having social cost. So if you really have to take into account the congestion cost, all these different cost associated with congestion has to be taken into account. Highway congestion and infrastructure. High percentage of national highway system operates under congested conditions. That's what we are seeing, and this congestion is going to increase rapidly in the future. In 2013, it is forecasted that many vital um, highway system will be congested, and there'll be um, millions of truck hours which will be lost because of this congestion. Um, Here is a piece of statistics which says that 10 bottleneck creates 1.5 million annual truck hours of delay at $30 per hour. So this is one bit of statistics, but this is not all. Like, if congestions keep on growing in the same pace and at what it is now, uh, it would be a real devastation for the economy, especially the highway, because a lot of freight which were supposed to meet or supposed to move in railroad are right now are moving in the highways in the trucks. There was a study done by Federal Highway Administration. It is called the Freight Bottom Line Report, and it was basically a study done where freight which had been moving in railroad, if they move or if they divert over to other modes like the highways, it is a big devastation as far as congestion, as far as deterioration of the highways are concerned. The report basically says that the railroad should be kept running and it should be more vibrant, it should draw more freight, because that's the only way you can keep the trucks out of the roads, uh, which is going to happen if the railroad is not made more popular. And so there has to be more investment in the railroad. The problem is the Highway Trust Fund, which basically was created to fund the highway infrastructure, is getting depleted of fund. So in the future, it's not sure how much fund will be left to maintain the highways, leave aside the development. This slide basically talks about the gap between the dollars required for improvement and maintenance and what is available. It is seen that there is a big gap between the two. As we have said before, the Highway Trust Fund, which is the main source of fund to maintain and improve the national highway system, is slowly getting depleted of fund, and it is expected in the future, if other sources of fund are not obtained, then probably it will in a big time affect the maintenance and improvement of the highways. Now railroad is going for a big change now. It has changed from the demand for hopper cars or box cars to demand for flat cars, which again comprises of trailer on flat car and container on flat car. So if you remember, TOFC and COFC are both associated with intermodal movement. So intermodal freight transportation is a sector in railroad which is basically increasing much faster than uh, other means of transport in railroad, like the hoppers or the boxes. Now what happened is, the railroad had initially had experienced an excess of capacity, sometimes in the early 90s. After that, they had abandoned many railroads, both regional railroads and local railroads. But recently, in the last few years, it is seen that the demand for railroad is again increasing, and also government, both federal and state government, basically patronizes the railroad, because unless the railroad take the freight uh, off the highways, basically take the freight which moves in the trucks and get it moved by railroad, uh, it would cause more problem for the highways. So because of this patronage, the railroad is seeing an increase of demand, and especially in the sector for TOFC and COFC. But the problem is railroad haven't expanded its capacity for the last few years. So if further development of capacity doesn't take place, then there will be severe congestion on railroads. As it says over here, that it's projected that 30% of the network will reach its capacity by 2035. Again, these are based on some FHWA projections, that year 2035, that can vary again. Uh, but the basic understanding is some expansion of capacity is required. But how is the capacity expansion done? One way of expanding would be to have double track at most locations. When there is a single track, uh, a train which is coming from the other direction has to wait, uh, until both train meets at a specific station or specific junction where they can cross each other, where there is a double track facility. But this causes a big drop in the capacity for that particular segment. If the whole network is double tracked, then train can move in both directions, and this enormously increases the capacity of the railroad. And if the railroad companies like the BNSF, the CP, the Canadian Pacific, these major companies, uh, they have to get rid of the problem of congestion and capacity constraint. What they have to do is basically double track, and that's what BNSF is doing in many locations. They are double tracking many of their railroad network. But the problem is this double tracking needs enormous investment, and they are trying to find out different sources of fund which might help them with this expansion project. The waterway congestion is happening at both locations, like in inland navigation and also in the ocean ports. Um, if you remember, we have said that the inland navigation is maintained by the US Army Corps of Engineers. They had been doing improvement, but probably it's not enough to keep the uh, vessels moving without congestion. So it is observed that a big percentage of the vessels which move in inland navigation experiences delays. The other capacity problem is happening in the ocean ports, and more so in the west coast ports like the Long Beach and the LA Beach. But the problem is not only with the capacity at the water side, but also the the inland side of these ocean ports, where the freight has to be moved out of those port locations uh, to enable other ocean containers to unload those boxes. We have talked about the Alameda Corridor, which is basically a link between the Long Beach area and the inland destinations. There is a dedicated freight corridor which allows the containers to move from those ports into the inland terminals. Uh, so unless something similar is done in other locations, this congestion in the ports are going to stay. The other problem which many of the ocean ports are facing is that of the draft requirement. The ocean liners need a certain amount of draft when they come to the ports. Otherwise, they get stuck in the ocean bed. With the increasing demand for bigger container ships, the draft requirement also increases. So the Panamax ships, which carry in the tune of say 4,500 containers, and which requires in the draft of uh, say around 10 feet, but that requirement actually it would be 10 meters. So that requirement would be much more when the post Panamax ships, which will be able to carry say around 12,000 TEUs, 20 equivalent units. So because of these increased draft requirement, the ports has to increase the capacity, both as far as draft is concerned, as far as equipments for loading and unloading of the containers are concerned. So there is existing problem, and in the infrastructure in the ports, in the inland navigation, and unless there is investment to take care of those, uh, in the future this problem will increase manifold. So in these slides they talk about the deeper channels, investment in technology and equipment by carrier and port operator. I think we just talked about this in the previous slide. This investment in technology is required to speed up the process of loading and unloading. And the other aspect is in the information technology. Any sort of operation becomes seamless with the help of information technology, with the help of EDI, electronic data interchange. So unless all these move hand in hand, like investment in infrastructure, investment in information technology, congestion problems cannot be avoided at many locations. From this slide, we'll look into green supply chain. Now, this term is getting very popular now, making your supply chain green. A big aspect of this green supply chain is carbon footprint. So, carbon footprint is basically what is the carbon emission done while the goods are moving in the supply chain. So it's actually not only carbon dioxide, but also there are other pollutants which are emitted during the process of transporting goods from the source to the final consumption. The basic intent is we don't really want only the manufacturing to be green. So initial attention was given to how to make the manufacturing green. And now the focus is more towards making the whole supply chain green. So starting from the source to the whole transportation process, it has to be green, so that the sum total, the if you take into consideration the product life from its source to the very end, during the whole process from its birth to that consumption, what is the total carbon monoxide emission, that is taken into account. And the aim is to reduce the sum total of carbon monoxide during the whole process. So now the problem is, can companies be profitable and at the same time make or implement green supply chain? Some companies are they have basically embraced the practice of greening their supply chain to improve their corporate image. So basically they advertise that we are green. It's basically getting a recognition from the consumers that, well, you are serving the society as a whole by polluting, by less polluting the atmosphere. The the green supply chain is embraced by more companies in Europe than in US. That's because of the stringent rules there. Um, in US, the rules for green supply chain is not that stringent, but again, some companies are trying to make a close connection between increase of productivity and greening the supply chain. So basically they're getting rid of those activities which are redundant. So reducing those activities which are redundant, that lowers the cost of production. At the same time, it makes the production process green, or the supply chain process green. So re-engineering of the supply chain is taking place, and the re-engineering with two objectives: to increase profit, at the same time to increase or to adapt green supply chain. So those are the two objectives which are kept into mind when the supply chain is re-engineered. Logistics related impact on green supply chain. So as were discussing before, the different wastage points or wastage practices are identified. It basically serves two purposes. that if you take away some redundant activities, if you take away activities which were not uh, which were obsolete maybe, and replace them by newer activities, that not only reduces your cost but it also greens the supply chain. Like you had been using trucks which had been more um, fuel demanding, or it's less fuel efficient. If you replace them by more advanced trucks which are newer technologies, which are more efficient, so it will not only reduce the cost of fuel, but it will actually make the supply chain greener. Packaging and waste disposal. So packaging is done in transportation to transport goods from one point to the other, but it should be done in such a way that it reduces the cost of packaging. At the same time, it makes the process greener. Okay. Now we'll talk about two important terms: don't ship air and don't ship water. So let us see what is that. Um, don't ship air is, it can be again looked from two perspectives. One would be like, don't move your trucks half empty. Say you move, probably the capacity of the truck is say 25 tons, you are moving just 10 tons. So the rest is here. So you are not basically utilizing the whole space. So it is not fuel economic. At the same time, it is not green, because you are wasting, you are burning fuel, at the same time you are not getting that production. The other aspect is don't ship here is you should make your packaging in such a way that it is not too fluffy. Now, to make products attractive, companies tend to make bigger packages so that its consumers readily can see those items in the shelf. But the problem is, in making those items with bigger packaging, you are using up more space. So that's probably not very green practice. The other is don't ship water. Again, this can be looked from two perspectives. The one would be like, produce your goods at the closest point possible, or at as close as it can be to the consumers. So you need not transport water for a long distance. Get your water from the closest location. Okay. The other aspect of looking that is like, if you can transport your goods without adding water, it is always preferable, because adding water increases weight, it increases volume, and it consumes more fuel. So take the case of detergent. If detergent is transported in a solid format, like the granules, it occupies less space. But the moment they are dissolved in water, it becomes heavier, it becomes bulkier. So Walmart had started an initiative where it talked about, where it said that it would prefer detergent to be in the solid format, where the water is not added. Because again, it is true for many other commodities like Coke or Pepsi. If you can transport any of these cold drinks in a solid format, maybe just the ingredients, then mix the water at the final location. I know there is a processing plant required, because it has to be there has to be high pressured gas added with that, and so on and so forth. There are different process for that. But if that can be done at the last point, the transportation cost can be lowered. But again, these are all trade-offs. What is the investment required to do that? What is the cost saving by transporting it in a less bulkier format? So these are different trade-offs. So this is a continuation of the previous slide. We talked about packaging, how it can increase the appeal, but at the same time it takes up more space. So to make the supply chain greener, the packaging has to be as smarter or as less cumbersome as possible, so that it takes less space. The other aspect is the adding water to the product. So adding water increases the usability, but the problem is it makes it heavier and voluminous. Walmart had an initiative to with liquid detergent. So for detergents, if the water is added uh, with the powder or with the pellets, it basically increases weight. So to make the supply chain greener, it's better that the water is added at the last end of the trip, or it is not added at all. The other aspect of the green supply chain is the EPA's initiative for Smart Way Transport Partnership. So EPA, Environment Protection Agency, it is the organization which is responsible for uh, protecting the environment and also taking green initiatives in the country. So if you really want to know the fuel economy of any vehicle you want to buy, you can go to EPA's website. You can look into what are the fuel economies of different vehicles, uh, what are the different type of fuels which can be used, and how that helps the environment. The Smart Way of Transportation Partnership is it is also done by the shippers who can help carrier to identify sources of raw material, sources of um, other partners of the supply chain, uh, which on the whole makes the supply chain greener. Maybe it reduces the transportation, the actual length traveled. Maybe it is using a faster mode of or better mode of transportation, which is more green. For example, EPA propagates transportation by train than by truck, because train is much more environment friendly than the truck mode. Say 400 truckloads of freight can be moved in one unit train which has got 100 cars. It is much more fuel economic than truck. So in that way, the smarter way of transportation is choosing the right mode, right location, and the right supplier. The other aspect is what type of fuel is being used. You know that the ethanol added gasoline is greener than normal gasoline. There are also hybrid vehicles which run on both on gasoline and battery. So propagating use of greener fuel using hybrid vehicles, maybe electric vehicles, those are some of the options which are taken by EPA and also by other government agencies. Subway restaurant has actually shown how it can cut down on carbon footprint and different emissions by making their supply chain greener. So different companies, they are using this as a selling proposition that they are green, they're doing benefit to the society. So the consumers should acknowledge that fact that they are basically serving the society as a whole. Now, from this slide, we'll be talking a little bit about the fuel cost and consumption. Um, there had been swings in the price of gasoline, which is the main source of energy for most of the vehicles. Now, if you remember, we have talked about how the cost component of the carrier is estimated, and a big component, the variable cost, is the fuel cost. Now, if the fuel cost varies, it will impact in a big way the total cost per mile or total cost per ton. Because of this fluctuation in the fuel price, it becomes very difficult for the carriers to set their price, because they have, if they want to justify their cost based on the fuel price, they have to keep on changing the price. So if they publish a price today, maybe tomorrow that price is no more valid because the fuel price has changed. So from 2004 to 2008, the price increased. After 2008, there had been some decrease with occasional increases. So these are some of the wild swings in the price of gasoline which had been seen in the last few years. Now, air carrier is very fuel intensive. The biggest part of the variable cost is fuel, which is in the tune of 12 to 15% of the operating cost. In 2007, the fuel rose to 30% of operating cost, so that's a very big component. The other big component might be the cost of the crew and the driver and the pilot. So airline companies, when they estimate the price, they do that based on one standard fuel cost, and then it charges additional surcharge based on the revised fuel cost. And this surcharge, the fuel surcharge, it goes directly to the consumers, the users of the service. So say that initial base price had been, say, $3, and based on that they estimate the cost. So if there is some 14 cents additional increase on the fuel cost, there are some formulas which would be used to transfer that increased fuel cost to the consumers. Now, how the allocation is done, it depends. Again, that's a business secret. No one would like to reveal how exactly that allocation of the fuel price increase had been allocated on individual tickets. Now, water carriers are much more fuel efficient than air and truck mode, but still, because of the price increase in the fuel, it had affected the price of the water carriers. The water carrier, as it says over here, in 2008, the fuel price rose. The marine bunker fuel price rose 100% from 2005 to 2008. So that was a big impact on the cost. The water carriers does also impose fuel surcharge, but the problem is because of the intense competition and because of the excess capacity in the water carriers, that policy of fuel surcharge may not be that widely used as in other modes. Rail carrier is also fuel efficient, as we have said that if the freight from the truck can be moved to the rail, it would be huge saving of fuel, because maybe 400 truckload of freight can be moved in just one unit train. So that way there's many researches done to see how efficient the railroad is compared to other modes. Similar to the railroad, the pipeline is also fuel efficient, and the cost of pipeline is not that significantly affected by the higher fuel cost. This slide talks about the fuel surcharge. As I have said before, there are some formulas which are used by individual companies to estimate the surcharge. You should understand that, say, a 5-cent increase of fuel cost, how exactly it is to be translated as an increase in price of service. Like you buy a ticket, you have an $20 fuel surcharge. So how that $20 is related with that 5 cents of gasoline or jet fuel may be increased per gallon. So that equation, that depends on what type of formula is used by companies. Again, that's not a very universal standard in that model for translating the surcharge or estimating the surcharge. There are some service capacity and national rationalization for this to reduce the fuel consumption. Some of it would be to reduce line haul, cruise speed. If the speed is reduced, then the fuel consumption reduces. It's applicable for air, water, and truck. And the focus is on shorter traffic lanes, so that you find the least cost path as far as maybe distance is concerned, cutting or reducing service on unprofitable routes. So maybe you have one customer which is located maybe at a location 20 miles away from your delivery point. So probably you will stop serving that customer because of that long route. So different measures based on greening the supply chain, greening your delivery can be taken to improve your environment consciousness of companies, and also to create that atmosphere, and to extend that information to the consumers that the company is green. And that's actually a selling proposition for many companies. Companies like Walmart, like JCPenney and Target, they all does that. They advertise that they're green in their process, they're green in their supply chain. Fuel cost and consumption. This slide basically talks about how a shipper or a carrier can make his fleet more fuel economic by having more efficient, lighter vehicle, which are more fuel economic. If you go to the EPA's website, they basically talk about what are the new trends of vehicles which are being used, vehicles which are having lighter body, which are having which produces more horsepower, but with relatively lesser fuel consumption. So those are more efficient vehicles, and that's the new trend. The other is the alternative fuel vehicle, like ethanol, which can be used along with the gasoline, or vehicles which are hybrid, or which can be electric vehicles. So those are the different options available for the carriers now. The other option which is available for the carrier and the shipper both is to use information technology to improve their operation, the efficiency of operation, like visibility, bringing visibility in the supply chain, knowing exactly where the container is, so that they can take more judicious decision how to deliver from the closest point. Say Amazon has to move a particular parcel or particular product to a particular customer in Texas. So if it knows exactly that product is available in Oklahoma, so they can ship it from Oklahoma, which would be much shorter than shipping it from Seattle maybe. So information technology in a big way can reduce fuel consumption. The other aspect is enable more timely and accurate information. That's also important, so that the car or the truck sitting idle is not there. It becomes more efficient, it becomes more synchronized operation. In that way, it not only saves fuel, but the whole operation of the company, whole operation of the carrier also improves. In this slide, it talks about the science part of the visibility. By science part, it means the technologies. So technologies like RFID tags, GPS devices. We have talked before that how RFID along with the GPS can bring in visibility in the supply chain, to know exactly where the truck is and what are the contents of the truck. So you can basically know when the delivery is to be done, where the delivery is to be done, and if any decision has to be taken, like the route has to be diverted to some other location, that decision can be done more judiciously. It can be based on fact than by mere intuition. The other aspect of that science is network optimization model. By network optimization model is, say you have a fleet of trucks, a fleet of 100 trucks, and their number of deliveries are to be done across a certain geographic extent. So you can run a network optimization model and then determine what should be the route of the trucks for delivering to those terminal locations or to the customers, so that the overall cost of delivery is lowered. So in lowering the cost of delivery, you are not only benefiting your company, but also you are benefiting the environment, because you are burning less fuel and emitting less carbon footprint. So that way it becomes beneficial. The other aspect would be the warehouse management system, transport management system. These are all information technology driven decisions taken, so that you know exactly where your goods are, how much of those goods are available, or how much of inventory is available in your warehouse. So you can take more judicious decisions, and for each of these information technology driven softwares, you not only lower your cost, but you actually pass on that benefit to the society in the way that you consume less fuel, you consume less manpower, and you make the system more efficient. In this slide, it talks about the art component of that collaboration and visibility. So when we talk about supply chain, it's not one organization, but it is number of organizations which work side by side to make the process successful. So you can implement the best of information technology, but unless the collaboration with your partners, collaboration with your um, service providers, unless you establish that service, you cannot be successful. You cannot make your system efficient. So this slide basically talks about how you can make that relation between other players of the supply chain with the service providers, like uh, the carriers, how you can improve the service at the distribution center, what type of manhandling can be done uh, at the different locations, so that the system becomes more seamless, more smooth. But the essence of this is in implementing this art and science of collaboration and visibility. You improve your system and you help the society by emitting less carbon monoxide, carbon dioxide, and other um, different pollutants in the atmosphere. So it is a win-win for both. So that's the basic essence. Like, a company can be green, but to be green, if it can become more profitable, that's a better option. Instead of, in order to be green, you have to spend this much amount of dollars. So that may not be sustainable for a long time. This slide again talks about the art of visibility and collaboration in the supply chain. It talks about VMI, vendor managed inventory. Uh, I think you have done this in some previous class, where the vendors are allowed to share information with the retailers, so that they can know exactly what's the inventory in hand at the retail location, um, and how much is in how much is to be supplied, maybe in the next few days or next few weeks, so that they can prepare themselves. So this is basically a sharing of information between the retailer and the vendor. If you go to Walmart, say you check out a item, and if it is an P&G item, Procter & Gamble item, and there is an agreement between Walmart and P&G, so that there is knowledge sharing between these two partners. So immediately item is sold, it's not only reflect in the um, database for Walmart that one inventory is reduced, the information goes to P&G as well, so that they can know how is the sale of that particular product, um, when they should prepare, when they should ship the next item, next lot of item. The basic advantage of this is uh, the vendors doesn't have to wait for the retailers to give them information or give them order for future deliveries. They know right away how much would be the demand in the future. So the forecast, it becomes more accurate, it becomes more timely that way. This also reduces out of stock. This reduces the safety stock. Uh, this basically smooth the flow of product through the supply chain. So this type of collaboration uh, between the different players of the supply chain increases the overall efficiency. This slide again talks about visibility of asset such as inventory, location of equipment. Now, visibility is used in different um, ways or different. This connotation stands for different. This has different significance to different business entities. Like if you take the oil and natural gas drilling companies, the companies who basically drill out gas maybe in the southern part of Texas or western part of Texas, for them visibility means more asset visibility. They want to know exactly where their drilling rig is, where the pipelines are located. So for them that is the visibility. Excuse me. For a carrier, their visibility might be to know exactly where the truck is uh, and what is the content of the truck. Is there any pilferage? If there is something stolen from the truck, if it is exactly in track, whether it's in time, whether it's in the route, in the perfect location where it is supposed to be. So for a carrier, that's the visibility. But again, uh, the problem with globalization is the visibility becomes much more complex because it's moved from one mode to the other. So you enable visibility in the truck, but when those containers move from truck to the ocean liners, to continue that visibility becomes difficult because the standards of technology for data transfer may not be the same in different modes of transportation. So we talk more and more about this visibility because that brings in uh, more smooth supply chain, smooth flow of goods from the origin to the destination. Now, different aspects of our, this visibility is RFID, GPS, cell phone technologies. I think we talked about this RFID and GPS, how they can be integrated to bring about visibility and to track product. If a particular shipment is stolen, then there are devices which will enable the law enforcement to basically track that container. This container basically emits a signal and it has a range within which the signal is available, and this enables the law enforcement to track it. Now, the people who are stealing, they are also getting sophisticated, so they can jam those signals. So there are technologies for jamming signal as well. So it's a constantly evolving process, the art and science of uh, making the supply chain better and more efficient. There are also technologies which provide alert if time and temperature move out of control. That may lead to supply chain design operational movement. So before a particular shipment gets damaged, say you are moving some fresh fruit in a container, so the temperature has to be maintained. If there is some problem with the temperature, there are ways that signal can be sent out to the central location or the central hub where they can basically decide what should be the next line of action. The other big area of research which is happening in supply chain is called business analytics. Business analytics is there are some trigger points set along the supply chain. Those triggers basically collect information real time. or periodically. Sometimes it may be real time, sometimes it can be periodical. So these signals are studied, they are analyzed to see if the supply chain is working efficiently or not. Business analytics is basically a new stream of math, maybe, or operations management, which basically help companies to understand if they have to take um, any particular decision beforehand, so that the actual disruption doesn't take place. So say a failure might happen in a plane, in a airplane. So there are devices which collect signal from different locations of that airplane, send it to a central location where it is analyzed, and that analysis will tell the system, or tell the uh, if it is a software driven, it will tell the software that some action has to be taken because uh, certain signals doesn't seem to be correct. So this particular branch of um, operations management is called business analytics. So if you have interest, probably you can pursue that stream, or it will basically come along when you start working in different fields that applied business analytics. So we have reached the end of this chapter, um, and that's the end of the course. So thank you all again for enrolling in the course, and following patiently with all these lectures and all the slides and handouts. If you have any problem with any of these slides, any of the presentations, please give me a call, send me an email. I look forward to have more interactions with you in the future. Thank you again.